Hello learners, in this lecture we will see what is the importance of a water cement ratio, and we'll also try to understand the maturity concept of the concrete. So we already understood what is water cement ratio and all, but still we'll try to see them once again. The water cement ratio is one of the major factors which influences the strength of the concrete. It is mainly responsible for the porosity of the hardened cement paste. Water cement ratio is the water which is used to quantum the cement in the mixture by weight, right? We always represent that by water by cement ratio. To put it in a better way, this is usually what we write. We say water by cement ratio. Let us consider it is to be 0.4. So with this, we can find how much amount of water is required or how much amount of cement is required, right? If I know the water content and if I know this water cement ratio, and if you cross multiply that, that will give me the cement content. Or if I know the cement content and if I've chosen my water cement ratio as 0.4, that will directly give me the water that has to be added in the mix. Any reduction of water results in incomplete with the cement and reduces the strength of the concrete, right? That also we have seen initial when we were understanding the chapter 1. We require minimum 23% of water for the hydration to happen, right? And then the 15% extra is required for the pour water and all. So whereas extra water beyond the minimum quantity required will cause the separation of the coarse aggregates, and the rich cement slurry escapes through the molds or through the formwork. So this results in the formation of the honeycomb concrete, which is weak in strength and durability. And we also understood this, how the honeycombs are formed and how it's going to decrease the strength of my concrete and all. So thus the strength of a concrete is basically governed by the water cement ratio and is independent of the ratio of the cement to the aggregate, right? So next is about the factors which affects this water cement ratio. We'll quickly go through that. So the first is about the quality of a cement that you're going to use, right? If the quality of the cement is good, then obviously the strength also will be good. So this is the first factor. The second is size and shape of the aggregate, which you already understood. If you're using a good size of aggregate and if the shape is angular, then it will have a better interlocking. As a result of that, it will have a good strength, which indirectly affects the water cement ratio. Then we have the surface texture of aggregate, then the concrete mix proportion, the way you mix the concrete and the way you take the proportion also affects the water cement ratio. Next is the grading of aggregate, whether you're going for a well graded aggregate or a uniform graded aggregate. So based on that also the water cement ratio is affected. Next is again the use of admixture, which plays a very important role. We already seen that if my water cement ratio is less, my strength is going to increase. Even from the graph it's understood, but we'll not be able to achieve the workability. But in order to achieve the workability, we can try to make use of admixture. So this also affects my water cement ratio. Next is procedure for the batching, how we are going to do the batching, whether it is volumetric batching or a wave batching. Based on that also it's going to affect. And last is about the method of mixing, placing, compacting and curing. So ultimately it all depends to curing also, because how good the curing is doing, how good you're doing the curing, what kind of curing you're making use of. All those are the factors which affects the water cement ratio, right? So you can see the graph as well. We already understood this. Now coming to the important thing, that is about the maturity concept of the concrete. So first we'll try to understand. So far, whenever I told you that the concrete is going to gain the strength in the first 7 days of 0.67, that is 67% of the strength is gained in the first 7 days. Then in the 14 days it's going to gain around 0.85, that is 85% of the strength. So there we were concerned only with the time, right? We did not take any other factors. So when we speak of maturity, for us only time is not important. Only with the what is that, passage of a time, the concrete is not going to gain the strength. There are certain other factors which actually affects the strength of my concrete. So that has to be understood with the concept of maturity. So as I mentioned, so far we understood the strength in terms of time, right? But now the strength of concrete actually depends upon both. It depends on time also, as well as the surrounding temperature during the early period of gain in the strength. So maturity of a concrete tells us how much concrete has gained the strength from its total strength. Let us say 25 newton per mm square or 25 megapascal is the strength of my concrete, or let us say it's the grade of my concrete. Now after 10 days I want to see how much strength my concrete has gained. Now if you ask me, we have the very straight formula, right? Let us say instead of 10 days, I'll make this as 7 days. Now how do you calculate this? Because from the previous lecture we understood, At the end of 7 days, my concrete is going to gain 67% of the strength, that is 0.67, isn't it? Now, how do you answer this? 0.67 into 25 if I do, let me do it. I'm getting 16.75. Let us say at the end of 7 days, my concrete is going to gain, at the end of 7 days, my concrete is going to gain 17 Newton per mm square as a strength. This is good. This is what we are getting from that particular chart what we have prepared. But the maturity concept tells us it doesn't only depend on the time but also the temperature. Now how do you understand this? Let us say I'm giving two options. I'm placing a concrete in Jammu and Kashmir, let us say, or somewhere in Himachal Pradesh, and that too in the month of November and December, which is very cold, which goes somewhere close to -1 -2 degrees Celsius over there. And on the other hand, I'll give you a place in South India. So in the now in the month of November and December, which is somewhere hot. So let us say you are somewhere in Bangalore now. So now in both the place you're going to place the concrete on the same day at the same time, let us say. And after 7 days in Jammu and Kashmir, you may get a different strength, and in Bangalore you may get a different strength, because as I mentioned, it depends on temperature also, right? So that is what the maturity concept tells us. Anyhow, we'll be taking up one problem and we'll try to understand how this actually is practiced in a right way, right? So this is the concept what I want to tell, that maturity can, I mean, the strength of the concrete doesn't depend only on the time or the chart what we're using. It depends on the surrounding temperature. Yeah. So the next is that it is a parameter. Yeah. So it is a parameter which indicates the fraction of a strength gain at any particular age. So maturity defines that the strength gain is not the factor of age only, that is regarding the time, but also the surrounding temperature, the surrounding conditions, and the temperature during the curing. So these are the factors which depends on the strength of my concrete, which has to be understood by the maturity. Right? Now we'll try to go one step ahead. So this is how the formula is given. The maturity of a concrete is defined as a summation of product of time and temperature, obviously, because as we understood, it is depending on time and also the temperature. So that is why maturity is equal to, it's a summation of time into temperature. And it was experimentally found that, now there is a lot of research has gone into this, right? It's not that suddenly someone came and gave that this is a formula. No. So there is a person, we'll try to, so who is that person? They did a lot of experiments and all, and finally they have come to a conclusion that it was experimentally found that hydration of a concrete continues to take place even at a temperature of -11 degrees Celsius. So therefore, -11 degrees Celsius is taken as a datum line for computing the maturity, right? Now what do you understand by this? That means, yeah. So the temperature is reckoned from a origin lying in between -12 to -10 degrees Celsius. So actually, when they were taking out this, doing this research, they found that the concrete is going to gain the strength. The hydration of a concrete will happen at a temperature of -10 to -12 degrees Celsius. So they have taken average out of this, and they have taken -11 degrees Celsius can be taken as a datum line, as a reference line. In surveying also we have certain reference line and all, right? Like if we do the surveying work and all, we have certain benchmark and all, right? So it's the same thing what they've done. They've taken a certain temperature as a benchmark for them, and that temperature is -11 degrees Celsius. So it was experimentally found that hydration of a concrete continues to take place up to about -11 degrees Celsius. Therefore, -11 degrees Celsius is taken as a datum line for computing the maturity. So who is that guy? The name of that man is Plowman. As per Plowman, -11 degrees Celsius is a reference temperature what we need to take. So again, to put it in a better way, will the rest things is understood to us. Whatever I've explained, I've written it in this way. I won't go through this. It's also understood. If somebody asks you what is maturity, the maturity of a concrete is defined as a summation of a product of time and temperature, because only with the time we cannot tell the strength. For us, the surrounding temperature is also important. That is how this is given. Now, based on the experiment and all, by taking -11 degrees Celsius temperature, they have taken certain standard, and they have found a sample of concrete which is cured at 18 degrees Celsius for 28 days is taken to be fully matured. That means this concrete, which is tested on 28 days, and the temperature which is 18 degrees Celsius, we can tell that it is fully matched. It comes out to be fully matured when it reaches this particular temperature. So this is the calculation what they have done. Okay, so we'll see how this has to be done. That is 28 is the day given here, right? So we have taken 28 here into 24. Why this 24? Because the answer has to be in hours. So this is 28 days. So each day we have 24 hours. So 24 into 28 into 24 we have done into, this is the temperature what we have at, this is a standard temperature where we have done the curing of this concrete. So 18 degrees Celsius is 18 minus, and this is minus 11. Minus 11 is the standard reference temperature that we need to take. And if you do this calculation, you will get this particular answer. But since this is a kind of experiment, there can be error and all, right? You are not sure exactly whether this answer is right or not. By taking a margin of fact safety factor, what they have done, they have rounded it up to next value, and that next value what we have is, yeah, so you can see it here, 19,800 degrees centigrade per hour is the temperature for the full maturity to attain. Actually, by calculation, we are getting 19,488. But since the temperature can go to 10 to minus 10 to minus 12 degrees Celsius, but we have taken minus 11, there might be slight variation here and there. So to be on the safer side, what they have taken is, this is the value what they have taken. So maturity concept is used for estimating the strength of concrete at any other maturity has a percentage of strength of concrete of known maturity. So in other words, if you know the strength of concrete at full maturity, that full maturity is obtained at this particular temperature of 19,800 degree centigrade hour. We can calculate the percentage strength of identical concrete at any other maturity by using the following equation given by the plowman. And the equation what he has given is this one. That is the percentage of a strength at a maturity of 19,800 degrees centigrade hour equal to, so this is important for us, A plus B log 10 maturity upon 10 to the power 3, right? And what is this A? A and B are the plowman's coefficient for the maturity of the equation. He has given this table. Again, this table has come through all the experiments and all. They might have taken different samples, they have done the tested for years, and then they with the help of some experiments and all, no, they have come to this conclusion, right? Yeah. So how do you understand this chart? It's very simple. So if your grade of a concrete is less than 17.5, then I have to take a coefficient of A has 10 and coefficient of B has 68, right? And if my grade is in between 17.5 to 35, then I have to take my coefficient of A has 21 and B has 61. Similarly, based on that different grade, this A and B have been worked out. So once you get this, you have to substitute the corresponding A and B value in this particular equation. So maturity will be given. They're going to ask you on what particular date you have to find the maturity of that. And if you try to work out this, you're going to get the final answer. And that will tell us whether your concrete has gained that particular strength by the end of 7 days or not. So what is the practical application of this? The practical application of this is, it will tell us whether I need to take out my form work or not, right? Let us say if let us say you're doing a concreting work in Himachal Pradesh, and you're doing a concreting work in southern part of India, let us say Bangalore. So due to temperature variation, the strength gain will certainly differ. You may take out the form work at the end of 10 days in Bangalore, but the same concreting what you have done, there are chances that your concrete might not have gained the same strength by the end of 10 days in Himachal Pradesh. But in order to understand that whether at the end of 10 days the strength has been gained or not, we try to make use of these equations and we try to find out whether that much strength my concrete is able to gain or not. So this is the practical importance of this, right? Yeah. So the same thing I've added it here. Okay, this is not required. Whatever was there, I've taken it from the some other textbook and I've added it here. Yeah, right. So I hope this basic understanding is clear about the maturity of concept. Again, there is more to it, but this is enough for us to understand how the maturity of concept is, how the maturity concept is to be understood. So in the next lecture, we'll take up two different problems on this and we'll try to solve them by applying the same formula what we have seen. So we'll see you back in the next lecture. Thank you.